All right, Namaste everyone, and welcome back to our course on time series analysis and forecasting. Going from a noob to a pro, right? So, in the last video, we went over a few basics and discussed the overview of the whole course in the curriculum. But this is where it all begins, and I'm super pumped. This video also marks the beginning of section 1 of this course, the time series concepts, which in my opinion is the most important and foundational section of this course. So you must go through this, right? All right, so let's get started. Now, before diving deep into what time series analysis, forecast, and everything is, let's first also understand what is time series and what makes it so special, right? So before going into the definitions and nitty-gritties of things, let's just observe few charts and plots here and then come up with our own definition of what time series is and build an intuition around it, right? So what is this? These are the sales numbers in billions of dollars in retail stores of USA, right? So how much the retail stores, they're earning year on year, right? So if there's 1996, so this would be 97, this would be 98, this would be 99, and this would be 2000, and then 2001, right? So these are year on year numbers in billions of dollars, right? So let's just try to study this and make some observations. So the first thing that we can see is that on the x-axis we have years, right? And on the y-axis we have the value, the dollars, right? The sales numbers, right? Another thing that we can notice is that if you take an overview of the charts, you can see that overall there has been a growth, right? There has been growth here, there has been growth here, there's been a little dump here, but again we saw growth. So if you join the first point to the last point of this chart, you will observe that there has been growth. So let's also take this down. So first thing that we notice is that we are plotting values against what? Against years, which is a unit of time, right? So this was the value that we are plotting here in this chart, and this is the time. So against time, right? The second thing that we notice is that there has been overall growth, right? So overall growth. Another thing, if you carefully notice, is that every year the sales numbers are repeating the same pattern, so to speak, right? So it starts from the bottom, makes some sales, right? Spikes up, near the end of the year, then goes down to the bottom, then comes up, makes some sales, the sales spike up in the end of the year around December time, then go down, then again make some sales, spike up, go down, some sales, spike up, go down. So this pattern repeats every year. The same pattern repeats every year, right? So let's see. So repeating pattern. And what is the pattern? It starts from bottom, some sales, spikes up in the December, then goes down, then comes back, some sales, comes, yeah. So this pattern repeats year over year, right? So these are few observations that we've made. Okay, so let's go on and see few more charts. All right, so what is this? This is the chart of temperature in New Delhi, India. Okay, and this movement marks the lowest temperature of that month, right? So this is a month over month chart, and this red dots are marking the highest temperature of that month, right? So if you can notice, in January it starts from the lowest, goes up, goes up, goes up till April. May, summertime, so this was winter, this is peak summer, May, June, July, right? And then it starts coming down again. So we are back to winter. And Same is happening with highest temperatures as well. Goes up, then comes down, right? And you can be rest assured that this is somewhat of a pattern that repeats every year, right? The year starts with winters. In the mid-year, we see peak summers, and then again we start going back to the winters, right? Another thing that you can notice here is that months, which is a unit of time, temperature, right, which is the value that we are recording, right? So first thing that we noticed here is value plotted against time. Second thing that we noticed was the pattern would repeat every year. That is an observation that we've made all over life, right? About the temperature of New Delhi and temperature of any city. Actually, temperature of any geographic location repeats year on year, year on year, year on year, repeats year on year, right? And then third thing that we noticed was that there was growth and then there was a dip. Okay, let's check out another plot. First things first. This is what? This is March 2021, this is May 2021, July 2021. So this is what? Again, months, which is a unit of time. And this is what? This is the price in USD of which share? Of Google. And the parent company is Alphabet, right? So what we can observe here is value is plotted against time. Second, the stock price, let's see what happened. It started here in this year. Overall, there has been a growth, right? You can just join the first point and the last point and see that, okay, overall there has been a growth. So overall growth, all right? And can we deduce any pattern in each month? So May has what? May, June, July. So this is the month. March, April, and this is June. So can we notice any pattern? There is a growth, but the pattern is not similar. Okay, so no pattern, no repeating pattern would be a better way to frame it. No repeating pattern observed. Okay, and this is just observation with naked eye. So going forward, we will see how to actually determine if there is a repeating pattern or not. So let's go forward. Okay, so let's continue our exercise with a little different kind of chart. So what we can see here, we can see that this is years, which is a unit of time. Then we see three charts, right? So this, what is this? This is demand. Demand of what? Demand of goods, right? This is what? This is precipitation at that time of the year, right? And what is this? This is the temperature. So what are we trying to determine here? What we are trying to determine here is that is there a correlation between the demand of goods and the precipitation in that area at that time and the temperature of that area at that time, right? So let's compare these two first. You can see that the demand patterns are repeating year on year. So this goes up, comes down, goes up, comes down, goes up, comes down. So it sort of has a pattern like this year on year, but there is no such pattern in precipitation, right? Spikes sometimes, goes down sometimes, spikes sometimes. Like here in the starting of the year there is low precipitation, but in the next year there is comparatively higher precipitation. Then no pattern, whereas there is a presence of a repeating pattern, right? Again, so we can conclude that there is no observable correlation as such. Like from our naked eye, we're not able to draw out a correlation. Maybe statistically going forward, we may be able to detect some pattern, but as of now, we are able to conclude no correlation between these two plots. Okay, so let's also then try to draw out some correlations. I mean, it's pretty visible to me. The demand is increasing with the increase in temperature, right? So the demand is increasing with the increase in temperature, and the demand is decreasing with the decrease in temperature. Again, increasing, increasing, decreasing, decreasing. Ta-da! Bingo. So there is a correlation between temperature and the demand of goods. Awesome, awesome, awesome. So what is this? This is your heartbeat, ECG. These are the seconds, which is a unit of time, and then this is your heartbeat. Cute. All right, so let's see. Again, the value is plotted against time. Perfect. Condition 1 is fulfilled. Now let's see. Is there an overall growth? No. Overall, we can see that the heartbeat is pretty stable. It's actually spikes up. It goes up to this level, right? And stays between this range. So it stays between this range, which is what should be the case for a normal human being, right? And for any animal for that matters. So also let's see if there is a repeating pattern every second. So there is one pattern that I can observe as of now, is that there is one spike and one dip, one spike and one dip every second, although it does not happen at the same timestamp, right? So this happened near the end of the second, this happened a little earlier, this happened even earlier, this happened even earlier than previous one, and this happened almost at the start of the second, and then another one at the end of the second. So we can conclude that there is some pattern, but not exactly repeating at the same time. Some repeating pattern, right? And these are similar plots. These are similar plots. So yeah, sounds good. Sounds good. So some great observations that we've been able to make in this exercise. Now, from this exercise, you must have noticed few things, that these all plots were, the values were plotted against time. Some had repeating patterns, some did not, right? Some had, some did not. And then there was some growth was observed in some of the charts, and it wasn't observed in some of the other charts, right? And a few other things. We also drew some correlations. So this was actually a great exercise in building our intuition of what time series are, right? This was the fun constant in all of those charts, right? So you can be rest assured that all time series data is recorded against time. So time series data is recorded against time, right? This would be the conclusion that I would make from that exercise. As a complete layman, this would be the conclusion. So if you'd give me those 4-5 charts and say that all of them are time series charts, what would we conclude about time series? This is what I would conclude, right? So now let's get into the actual definition of things and see how close we are, right? So what is time series? Time series is a sequence of data collected at regular intervals of time, right? And over a specified period, right? So regular intervals every year, every month, right? Every day, every week, even every minute or second, right? So this is what is regular interval of time, right? And over a specified period. So this, yeah, so every data set that we saw was over a few years or over a few seconds or over a few months, right? So that is the specified period. Now, few other things about time series is that observations are comprised of real numbers, right? We did see that. We saw dollars, we saw temperatures, we saw heartbeats, ECG correlograms. So those all were real numbers. It has continuous value but is discrete in time. Interesting, interesting. So if you consider the sales chart, right? So it was repeating every year. Overall it was something like this, right? So values were continuous in nature, but every timestamp had a discrete value associated to it. This is what this sentence means, right? And it was time dependent, right? So time is the independent feature. So this comes from the machine learning side of things and data analysis side of things, where one is the dependent feature and other is the independent feature, right? So if in machine learning we are trying to predict sales, right? So there would be a data set like this, and this would be the dependent feature and these would be the independent features, right? So similarly, a time series data also looks very similar. So this is the time and this is the value, right? So this is the independent feature. So let's summarize everything. So time, what is time series? Time series is a sequence of data collected at regular intervals of time over a specified period, right? So any data that is recorded by the time. So if you're recording the temperature at every hour, right? If you're recording the sales every day, right? If you're recording anything for that matters against the time, so that is a time series, right? Or time series data, or even time series process. These are different names given to the similar things. So with this exercise, we have built an intuition around what time series data is and what it looks like as well, right? Awesome. Let's go ahead. Again, anything and everything that is measured over time is time series. Okay, so now that we have understood what a time series is, let's also look at how it is represented mathematically, right? Also, do note that in different textbooks and different articles, you'll find different ways of representing the same equation, right? So please do not be confused with that if you encounter a different form of the same equation, right? The maths out here, at least in this course, is only to strengthen our theoretical concepts, right? And not to make it more difficult for ourselves, because at the end of the day we want to implement the algorithms and we want to implement the concepts that we are studying, right? So mathematically it can be represented as y of t, right? So this is our time series and it can be represented at y1, y2, y3, yada yada yada, yt, yt minus 1, yt minus 2, yada yada yada, and it goes up to y, t of n or whatever, if there are n number of timestamps, right? So just to visualize it, you can visualize this equation like this. So if this is your table, right, this is your time component, this is your value that you're recording for each time. So this would be t1 and this would be y of 1. This would be t2 and this would be y of 2. This would be t3 and this would be y of 3, so on and so forth, right? You can also summarize it like this. So a series of yt minus 1, yt, yt plus 1. So there is a consecutive increase of one timestamp, right? That is what we can notice. Another way of representing a time series is y equals yt for all t belonging to the timestamps. So this is also another form of representing the same equation. everything means the same, right? So the T is the units of time, right? Okay, all right. Some more examples to solidify our understanding of what time series data is, right? So this is a very popular data set, and this is like a sneak peek into what's coming your way, right? So this is what the table would look like. This is what the data set would look like in a table, right? And this is what its plot would look like. So this is number of passengers every month of an airline, right? This is a very popular airlines data set, right? Let's make the observations again. These are years, right? The value is plotted here on the y-axis, which is thousands of passengers, right? So one is value plotted against time. Okay, if you check out the first bit and the last bit, there has been constant growth. So growth observed. Okay, so let's also see what's happening here. So this is 52, this is 53, this is 54, so, and this is 49, 50. Okay, so you can see that there is a pattern that is repeating every year. And what is that? Bump, dip, a bigger bump, a bigger dip. Okay, bump, dip, bigger bump, bigger dip. So it's repeating like this year on year, right? So there is a repeating pattern as well in this chart particularly. Now mind you, every time series does not necessarily have some growth or a repeating pattern for that matters. Like we saw that precipitation chart did not have any pattern, and we saw that the heartbeats chart did not have any growth over time, right? So but this chart does have, and this is a very popular chart. We'll do a lot of exploration and exercise on this chart, right? So some of the popular time series data are stock market prices, right? Like the one we saw for Google shares, right? And we will do a lot of prediction on stock market prices, right? Okay, again, weather is a very popular time series data. We often check weather forecasts, right? So temperature, air pressure, precipitation. We've seen examples of this as well. Performances, so sales, right? Then traffic on a website, right? At every minute, how many traffic is there? GDP of a country, right? How anything and everything is performing over time. That is also time series data, right? A valid time series data. Health, right? Time series has a lot of use cases in the healthcare industry. So ECG, what we saw, SpO2, the oxygen levels of a person, right? Calories burnt over time. So these are some of the popular time series datas. Alright, so we've reached the end of this video. So just to summarize, we spent a lot of time discussing what time series data is and understanding, how it is different from the regular data. Going forward, we will dissect this further and try to understand its features and properties and components, which will help us really appreciate the novelty of this type of data sets. Okay, so before ending, I really want to highlight that do not forget to check out the description of this video for additional resources and practice exercises and assignments I may have regarding this discussion. Alright, so finally, do like the video. If you like the video, do share it with someone whom you feel would benefit with this. And if you have any feedback or any query, any doubt regarding this discussion, do drop them in the comment box below. Alright, thank you, and I'll see you in the next video. Namaste.